Hello. Hey, I think it's working now. Hello. Hello. I think it's working now. I should go to washroom and back. But I'm scared if the stream will stop if I go to washroom. It seems working. Yeah, I think stream's working. Right. So previously I have opened 11600 problem. Let's try to go over that. See guys, why am I doing this stream? Do you know the reason why am I doing this stream? Maybe I'll get some practice. That's why I'm doing this stream. Because otherwise I'm not at all practicing this. Do you guys see? I mean, there are more reasons. I was just joking when I told this. Let's solve this problem called tree jumps. Okay, you guys ready to solve it? I'll go to washroom and come in a minute. Maybe you got something in your nose. If in that case, did you feel that? What was that question by you? Software engineer? Question mark. We're solving problems here, Kalyan. Kalyan. I'm just working at Apple. It's 1 year have been working. But can we? Who else is there? Okay. Did, okay, we got 5 viewers. So let's try to read the problem again. The problem says there is a rooted tree and distance increases from top to below. And when we are at a vertex V, we can go to a vertex U in the next level, but we cannot go to the neighboring things, it seems. So if we are at 2, we must go to 7. When we are at root, we can go to anything, it seems. For example, that in the tree above, these are the possible chip movements. You can go from 1 to 2 to 2, or 1 to 5, or 2 to 7, or 5 to 3, or 5 to 4, or 3 to 6, 7 to 6. The sequence of vertices is valid if you can move the chip in such a way that it visits all vertices from the sequence and only them. What the fuck does it mean? It's valid if you can move the chip in such a way that it visits all vertices from the sequence and only them in the order they are given in the sequence. Okay, a sequence is valid if you can visit all of them and only them. So if there is a if you can traverse that path, like 127 is a valid one, 1536 is a valid one, 1546 is not valid, 17 is not valid. So we just want to count number of valid vertex sequences. So it's like a brute force problem. So it's a very direct problem. Yeah. Thank you, Kalyan, for calling it as great buddy. I mean, I don't know your age or anything, so I'm just assuming you're a junior, but I think it's fine. So we are trying to solve this problem, and it just says number of valid vertex sequences is what we need, right? So we are at a vertex 4. Okay. We have all other vertices in that level. Let's say we are at a vertex V. Let's see, it's a simple problem. Yeah. So the constraint is you can go from 1 to 2 or 1 to 5 if you're at root. But if you're not at root, let's say if you're at 2, you can move from 2 to 7. That's valid. But you cannot go from 2 to 4 or you cannot go from 2 to 3. So now there are a sequence of valid sequences, right? You can go from 1 to 1, 2, and then you cannot go to adjacent. You have to go to next level, but you cannot go to adjacent. So you have to go to 7. You can go to 7. 1 to 7 is valid. 1 to 4 is valid. 1 to 1, 5, 3, 6 is valid. So this problem 2 to 6 is valid. No. We have to go from du to dv plus 1. Take some time to read the problem or else read it with me again. We have to go to the adjacent layer. Let's say we have layers. Layer 0, layer 1, layer 2, layer 3. We go from this layer to next layer, but we don't we don't go to the same thing. Like we cannot go to its children, but we can go to the anything next in the next layer, right? So we go to next level, but not to same children. So what are the facts that we have to consider in this problem? What are the facts that we should consider? Obvious facts that du equals to dv plus 1. So we only go down. So in all valid sequences, we only go down. Like we only go down. Like so, let's say now we have to count all valid sequences. How do we count something? Maybe we will try to, but not the children. Yeah, that's it. So it's a direct problem. All is it testing is we know how to do it. Like we just have to define. Uh, let's say let's generalize it a bit. Valid sequences starting at node V. Let's try to find these things. sequences starting at nodes v. We are generalizing it a bit more. We are trying to see, because if you are starting at v, let's say I'm trying to go down and go down, starting at v, what are the number of valid sequences? If we are trying to maintain this as, let's call it f of v. F of v equals to this thing. Okay. Now, what is f of v? Can we represent this in terms of some other elements? Like if we have sum of f of u, where u is, because v is there. Now, u has many options where u is in next level, but not children. We are done. Right. That's it. It's a simple problem. We cannot go to current level. We have to go to next level. Damn, again, just 2 viewers. People got bored already. There were 6. See, we have to go to next level. So you should be all the next level things minus but not children. So answer can just be f of v equals to sum of next level minus sum of f of children. Does this work? Is this fine? Yeah, you mean next level. I got it. So that's it. This is such a simple problem. And how is it 1600? Because people can't even read the problem after seeing it is trees. We just find level layer by level, layer by layer. Let's say we do BFS instead of DFS. We do BFS, like we have all the layers. And when we are at the previous layer, some when we have, see, it all uses like this complexity is fine. When we are at vertex V, doing number of visiting all its children is fine, because that will contribute to edges from V, and sum of edges is n minus 1. So sum of edges is small. So going over all of its children is fine. When you are at vertex V, going over its children is fine, because so at a vertex V, you are going over its edges. So O of n plus m complexity. And then it can be done. It's a simple problem. Let's try to do it like BFS, like layer by layer. And then we are done. Right. So let's just put them in layers. I will write the simplest BFS that we can write. We don't even use Q. Without even using Q, BFS. But what about root? So this is a direct and shitty problem. So what about root? For root, it's just sum of children. Right. ADJ will give us children, let's say. I'm just trying to implement it. So this is a simple problem, right? This is a common direct problem for anyone. No, 2 to 6 is not valid because you cannot do 2-layer jumps. You can only go to next level, not the next level. Okay. 2 to 6, yeah, that's valid. See, this problem is all about writing this statement, defining f of v as sequences starting at v and being valid. I mean, as per the valid definition, it should start from root, but we are generalizing their definition and then finding their definition. Because if you have this, we can find f of v using its children. That's the reason. So this is simple problem. We have done it many times. Like if from here, these are the different possibilities. Fix this. Okay, it can be this or this or this or this. So number of ways of doing from here, number of ways of doing from here, number of ways of doing from here and all. But then you realize that you cannot go over everything that's in the next level and in children, because there can be so many. But if you find the sum of next level minus if you do the sum of its children, then it will be just number of edges attached to V, because children are just edges attached to V. So it will be sum of O of M, because complexity is bounded by sum of edges, which is equals to n minus 1 here. Yeah, that's it. But then we have to write this recurrence. So DP is just brute forcing. Whenever we use DP, it's like just brute forcing, trying to find all possible ways. All possible ways will be from here. Is it? Yeah, it is. Trying to find next things. DP is brute forcing. It doesn't have any good things in it, right? So let's just try to find layers. How do we find layers? Very easily, I think. So I mean, X is the parent of I. So we push I into X. Why is it not showing? Baby, you got something in your nose. Within that can, did you feel the hole? I will make BFS. Okay. So let's try to make layers one after the other. Okay. We have layers of size n, n plus 1. Let's say we have layers of size n plus 1, and L of 0 will have uh, root node, which is 1. Okay. So now to form the next layer, what we should do? To form the next layer, we should add everything from this to the next layer. So let's also keep one int used added. Okay. Added of, I mean, this is a tree, so it's even simpler. We can just do BFS, and then according to heights, we can push them into layers too. Because, okay, I don't do DFS. I will just do DFS because it's a tree. Okay. Uh, let's just do DFS, simple DFS to form layers. So when we are at a height h, we are just pushing v into that, and then this is simple DFS, right? I don't want to use BFS because it's just a tree. If it is a graph, maybe BFS makes sense. If it's just a tree, we can just do this to traverse a tree, right? Tree traversal is best. This is basic DFS, and then I'm just pushing it into this layer. So this is such an easy problem. Like it has no logic. It has no logic, but writing this simple brute force recursion, which is a brute force recursion. From here, all possibilities we have to sum, but we cannot sum that much. So remove the small from the total. It's such a simple technique. Like it's like brute force. I think this is such a shitty problem that if you guys are not 1600 rated, if you guys are not solving these problems, such a problems in the contest, that's just waste of time or waste of giving contests. DFS of 0 comma 0 comma h. This would work. Sorry, 1 comma 1 comma 0. This will make the layers already for us. So now that we have layers, let's find f of n from previous layer. Let's start from, I mean, if you're starting from 0, it will only take till n minus 1, right? Maybe you got something in your nose. Within that cave, did you feel the hole? Hope you find peace. By 0 up to n minus 1 only, right? Max layers. So let's go from previous layers. We are coming from below, from previous layers. We have all layers. We are coming from below. Let's also have like sum of f for all layers. Okay, this is just sum of f for all layers. Okay, this will give us this sum of the next level, total next level sum. So Maybe let's just keep it like n plus 2, because so that f of n plus 1 will be empty anyway. Okay, this is just f of n plus 1. This is for vertices. This is for layers, just to maintain their sum. Okay. So we are going over all the vertices in this layer. Okay. Maybe you got something in your nose. This is NF because next layer to this is layer N, right? Layer. So we are going over all the vertices in this layer, current layer, and then f of v equals to 0 for int u. F of v equals to fs of next layer, which is I plus 1. So f of v equals to sum of next level. That's been done. Now we just have to subtract its children. F of v minus equals to f of u. F of v remainder equals to m. I'll add that too. Maybe you got something in your nose. I mean, all these things are simple things. I hope you guys can just understand these things so that I will not stress on them much. Now let's find SF of. We need not. Okay, SF of I. We'll try to find this thing. It has already been initialized to. You can just add it right here. SF of I plus equals to f of v. SF of I remainder equals to m. So we are finding everyone's f in this layer, and then we are adding it to the sum of that f, sum of f's in that layer, to this array. So we are done. Except at layer 0, we won't add anything because we have added everything and then we have subtracted anything. So let's just make int answer equals to, or f of 0, not f of 0, answer equals to sf of 1. Do you guys agree to that? Because f of 0 should have been sum of all of these things. We should not subtract anything. So that's also fine, right? Damn, for a second I got scared about whatever the discussion that people are doing. Yeah. So we have to make typical mistake that I do most of the times is this thing. I've ruined some contests just because of this thing too. Maybe you got something in the nose. See, somehow my thing is not working for variable size initialization, but it will work in other compilers probably. See, we are adding 0 and then we are not adding anything. So there is one thing we should do. When there are no children, when there are no children at all, then f of v should be 1, right? F of v is always 1. It begins with 1. Because not when there are no children. There is always a valid sequence start from there that doesn't consider children at all, right? So starting from v, if its length equals to 1, then one sequence we got. If length greater than 1, then we can brute force on its children's. So it should have been 1 plus 1 plus because empty sequence. So it's not even about leaves. The formula itself should have 1. Otherwise, if you're adding and subtracting zeros, it will not cost. It will not do anything. The only thing I missed was 1 alone. Root alone, I have missed that. I missed root being alone when I consider the other things. So you guys should realize it's not about getting great ideas. It's about being able to do the work. It's about being able to do the work, like being able to mentally check that, okay, from here, I have to see all the valid sequences. They can be of length 1 or they can be of length greater than 1. When they are length greater than 1, brute forcing. This clarity, this clear logical thing that you can put into the problem. So it's not, yeah. You guys think you cannot solve something because it involves greater logic or something like that, but it's not that. It's always about doing the work. And doing work is just a skill. If you keep trying harder, you will definitely improve it over time, right? So it is just a skill. And it won't even involve big things. It will just have a bit better things. So till 1600 so far we don't have anything, right? Till 1600 so far we don't have anything difficult. Let's see, when I used to solve like 1700, I used to solve like everything when I was practicing, not now. Mm-hmm. So what are 1700 problems? There would be randomly. So let's try to read this on. If it is counting, I can definitely do good. 1700. You would like to construct a string S consisting of lowercase Latin letters. Maybe you got something in your nose, sniffing that candy. Hope you find things for yourself. You would like to construct a string S consisting of Latin letters such that the following conditions holds. For every pair of indices I and j such that Si equals to Sj, the difference between indices is even. Okay, that means some character can occur in even indices or odd indices. That's what they mean, because we cannot have some character in both even and odd index, it seems. Oh, the difference is even. What do they mean by that? Yeah, that's what it is. Okay, this is simple. We have to construct such a string, it seems. Constructing any string is too easy. So you will be given an array of C of 26 numbers. The string is being easy. Now I'm half side shining. Haha. Guys, like the video. We want likes. Because people may see the likes and then they may try to see the video, or else they will not see the video. I'm not moving until I get one more like from here. I like myself. Okay, you like. Yeah, that works. Yeah, so now we'll read the problem. This string seems, the structure of the string seems simple. Yeah, if A occurs at even indices, it can only occur at even indices. Structure seems simple. Constructing any string is too easy. That's what. It seems too easy. So you will be given an array C of 26 numbers. The required number of occurrences of each individual letter in the string is. So we have this 2 now. The sum should add up to n. Okay, n is not given. And sum of Ci will not exceed this 2. So because we have to construct those strings. So this is just a counting problem. We have to count these things well. Now, do you guys get this problem? We just have to find number of distinct strings. So we have to somehow group what we want to count into nice things, and then we just don't do great things. We never do great things. What we do is we try to systematically make some statements and then we solve it. It's a direct problem for me. I'm just trying to make it easier for you guys. Nice. I also can solve this problem. So even strings. I can solve it quicker too, but I'm trying to make it as detailed as possible so that you guys can understand it well. So, so one thing is clear: n, length of string, can be known. First to sum of C. Sum of array C is length of string. Now we have any even indices, and which is nothing but like n by 2 or something, and odd indices, which is nothing but n by 2 plus 1 or something, n plus 1 by 2 or something. So now these 26 characters will be splitted if we try to look at one string. Okay. If you look at one string, if you try to look at one string, if you look at one string, splitting these 26 characters into even or odd. We can first split these 24 characters into even or odd. Okay. We are just splitting like it's going into even indices or it's going to odd indices. We don't care about other things. Mathematically, we need not care, right? If they will fit into even index or if they will won't, if they will not fit into even indices, we need not care that. But maybe we should care. Now it is any factorial. So if sum, and then we should split such that their sum equals to any. Then answer is nothing but any factorial by let's say in one case, if you just do this splitting, like C0 comma C1 comma C5 comma C7 went into even indices and rest into odd indices. If sum of if C1 plus C5 plus C7 equals to NE, then answer is NE factorial by C1 factorial into C5 factorial into C7 factorial. This is obvious. Like number of orderings when there is repetitions is by dividing by the that is there are many ways to think about that. You can think about okay that we can think about them like considered xxxx. I should not say xxx. I guess like consider y. If you have m y's, we see them as y1, y2, y3 up to on yn. But ordering among them is m factorial. That is redundant, right? Like that is not needed. That's why we divide by c1 factorial, c5 factorial, c7 factorial. This is obvious. So now any factorial is common over all possible splits we do. So what we have to do is we have to find a way in which we can group a few things into any. And so what we want is groupings that add up to NE and their factorial product, right? We want C1, C5 plus C5, which will add up to NE, and we want their products. So we want this. So let's try to generalize this and find this. Okay, generalize this in the sense we have 26 things, right? What all sums? So we want to find for all sums. For all sums, we want to find for all sums we focus on only even things. For all sums, we want to find sum equals to, let's say, S. We want summation of all possible uh, summation of taking few CIs, taking few C's that add up to S. We want this, we want their summation of their products. Do you guys get what I mean? Like, let's say C1, C5 will add up to S, and also C2, C3 will add up to S. We want summation of C1 factorial, C5 factorial. I mean, we want its inverse. We want this one's inverse plus C2 factorial, C3 factorial inverse, because, like, yeah, we just want their inverses. If you just see it like inverse factorial, we just want like C1's factorial into C3 factorial. Like, we want all this summation. Is this too hard if you try to use some DP? And if you try to find all these sums by considering first I characters and then consider the next character and then try to find the sums again, I don't think it's not too difficult, right? But for each of the thing, we have to go over everything again. Maybe there are simpler ones. I'll just try to think about it a bit.